While he's doing that, Greg is going to give us a live presentation of CAD software that you use with the printer. Okay, thank you, Greg. I'm going to turn it over to you. If you need anything, I'll be ready for you.
So, hams build things, right? This is what we do. We build things. What I'm going to do tonight, live dangerously, I'm going to do a live demo. I'm going to cover a little bit of the history of what we've been doing as this is normal stuff for us. Look at maybe another way of doing stuff, and then actually go in and do it live. Historically, who knows what an Altoids tin is? Yeah. How many has built this stuff in an Altoids tin? Yeah. Ammo box? Ammo box? Yeah. Okay. How many have spent hours walking the aisles of Home Depot with pieces of PVC pipe on your fingers, trying to figure out which ones they go to where? Okay. We use copper pipe. We use PVC. PVC is the universal building material, right? Who would have known? But what happens when you have a project like this? What do you build? What do you find for a box for that? And we graze the aisles. We look for things. One approach, so this was Greg's, what is this? Oh, offset attenuator. One approach is to design the circuit board to fit the box. The other approach is to build the box to fit the circuit board. So we're going to do that this time. What I did, so this was the my presentation from about a year and a half ago, or a year ago. I did my solar system. It's got a Victron charge controller in it, but there's no display. And so I designed a display circuit, and I built a box for it. I have you heard me on the coffee break net, I never time out the repeater, and this is why. I have a little box with a little display. It increments up. When it gets to the top, I'm going to stop talking because I'm going to time things out at 3 minutes. So what we're going to do tonight is I'm going to show you how to build that box live. There's the box and the lid. That was a test print. Inside, Arduino, some LEDs, stuff like that. You basically have a box. There are little standoffs at the bottom for mounting the circuit board on it, holes for the LEDs. You know, stuff that you would sit there with a drill and safety glasses, drilling holes in that thing from Home Depot. Or you can have them pre-punched in the box that you print. The lid snaps right on top. No screwing or soldering required. Okay. 3D mechanical drawing. Everybody has this image of 3D CAD, right? You see the picture of the jet engine and all the numbers and arrows and pieces, and they rotate it in 3 dimensions. You can see the thing spin, right? That's mechanical design. There's another way of doing mechanical design, which is very simple. You put in material and you put in negative material. It's called a hole. And you stick them together and you just build it up from there. And that's what we're going to do tonight. So there's the hole being positioned, and there's the hole when it comes in there. All we need to do this is pencil and paper, one of these. This is a digital caliper, amazing device, and some free software. First thing you got to do, you got to know what you're going to build. You don't sit down there and start designing things. I'm going to do it tonight, but we're going to make some mistakes. That's okay. You can see what's going on. You really need to understand what it is you're building by dimensions. So the box is going to be, we'll build a box on 100 by 50 by 50, or 100 by 100, 4 inch by 4 inch by 2 inch high box. Okay. We want like 2 millimeters of width of the plastic around it. And so then you start stacking these things up. You look at the, well, that's cute. There we go. So you got your dimensions there where you have the, there's your base, 2 meters up, 2 millimeters up is the start of this thing. You got some distance you want to have between these. This thing is thick. You stack them all up. You add up all your numbers to figure out where things are physically. Pencil and paper and your digital caliper. And then, this is FreeCAD. FreeCAD is free. It's an open source computer-aided design. It's really powerful. It's got a bazillion different modes to it. You can do animations. You can do all kinds of stuff. You can do that jet engine if you want. We're not doing jet engines tonight. There are tools across the top here. You've got parts of the, your component gets laid out here, and of course stuff is in the middle. The most important thing to start out with, you start out with the start thing down here, go up here, go to part design. That gets you this set of tools. You can click on the box. You now have, the navigation, shift and right click gets you this thing turning around here. And so there's the part, right? There's my cube. Now, we're going to make this thing 100 by 100 by 50. Okay, scroll out. That didn't sound good. So there's our box. And if I shift and drag this thing around, you guys can see this? We got our box here. 50. And this is just a cube of plastic. Okay, you're not going to do much. Now, you can take your Dremel tool, I suppose, and route out the middle of it, but we're not going to do that. Oh, one thing I missed here is we need to have this thing anchored. Come on. I'm living dangerously here. Okay, I forgot, you got to anchor it to one of the coordinate systems, the XY plane in this case. Very important. Okay, now, there's our box. And now we say, so these are the additive things. You're adding plastic. These are the negative things. So let's take out a subtractive box. And if we zoom in on this thing, you can see it down here in the corner. And as I take the length and make it bigger, okay? And the width, make it bigger, a little bit the other direction. Now, 100 by 100 is our size. We've got 2 millimeters on each side. So how big is the hole in the middle? 96, right? 100 minus 2 minus 2. So let's make this 96. We'll make this 96. And then for the height, 2 millimeters off the bottom, and even with the top. So that one's going to be 48. That make sense? And of course, we want to be on the XY plane. That's not the XY plane. Where's the XY plane? Go to there, there's the XY plane. Okay. So now, we can go down to this part, and if I look at this thing, it's hard to see here, but zoom in, you can see it's kind of off in this, there's the hole there. We want to move this thing around 2 millimeters to the side, 2 millimeters that side, and 2 millimeters up. And now, if I say okay, guess what? We got ourselves a box. That's all it took. Okay, I can import this thing, print it out, done. Oh, got a lid. We'll make a lid. Let's make some holes in it. So we have our box. This is looking straight down. Let's make a subtractive cylinder. Okay, there's our cylinder. Now, it's on the XY plane. There's an easier way, but I won't cover that right now. And there's our, so we just drilled a hole down in the middle. We need this thing, let's see, the LED is about 3 millimeters diameter, roughly. So the radius is 1.5. It's going to be 2 millimeters tall because that's how thick the side is. And it's going to be a full circle, it's a 360. Now, if we zoom in here on a little cylinder, we're in the wrong direction and wrong place. We move it across, and we'll move it up. Now let's move it. So here's our hole. Now that's on the bottom. We need to have this thing be rotated. One of these things is going to be rotation in the right direction. Can you see it turning? You see that thing turning there? Let's zoom in a little bit here as I'm doing this. See, I'm rotating it. We don't want it that direction. We want this thing to be 0. We want it to be like I said, we're doing this live here, guys. Okay, here we go. So this is going to be 90 degrees. And now it's this little circle in the middle of space. So let's move this thing down there. And if we look at the thing on the side, one of these sides, there it is. We got a hole. And you keep on doing that, and you get all the LEDs across the bottom. Let's move it over sideways, right there, okay? Make sense? Okay. Now, if we shift, okay, see the hole there? Little hole inside the box. That work? Okay. You put all your holes in. Oh, we need supports for the PC board. You can replicate. I've done that. It's a question about replication. You can replicate and then reposition it. Sometimes it's easier just to put a new one in there because the parameters are going to be different for each. The location will be different for each of them. So sometimes it's easier just to. That it's going to be 1.5 and the couple of the base things. It's easier just to put it in each time. We need some supports. So a little box down there. That's actually not a bad place to put it. XY plane. And just to be easy, we'll just do that. And so now we have, if we look at this thing here, see a little support in the corner? So we'll have 4 of those. So there's one. We can do another one here. And again, the XY plane. XY plane, here we go. And let's move the X direction of this guy. See him moving across there on the bottom? Move him to the other side here. And so now we've got a second one. And you get the idea. We put all 4 in there. One of the things I found in one of my boxes that I did is when you're going to insert these boards in, if you got things sticking through the holes, make sure the box is big enough that you can put it down and slide it into place. Otherwise, you can't get it in. That's why I have a second one over there. Missed that. Okay, make a lid. We do a new. A lid is, well, a lid's a big flat thing, right? Guess what? A lid is just 100 by 100 by 2, right? So I have that on XY plane. I don't have the XY plane. XY plane. Gotta have the XY plane. Wish we'd default to that. Okay, so that is our lid, but unless you want to glue it on top, which you could do, you want to have a ring around the inside, a little lip. So that's another box. And it's 100, no, it's not 100. It's going to be, what's the inside dimension? 96. By 96 by, so 4 millimeters is probably enough for the lip. Now notice I have the same dimensions on the outside of the lip as the inside of the box. There's no gap there. That's for a nice tight fit. And I was worried about how much slop I needed. The answer is 0. It just works out that way. We want to be on the XY plane again, and now we got to move it over a little bit. The X direction, 2 millimeters. Y direction, 2 millimeters. And we've got to be up 2 millimeters to have it on top. So now we've got, basically it looks like a little mesa there. That's a lot of plastic. So we got the lip there. That works. But what you can do is do a subtractive box on top, which is going to be XY plane. So another 2 millimeters in. That was 96 was the outside, 94, 92 for the inside of this one. 92 by 92 by 4. And move him up, so it's got to be centered by 4. And 2 millimeters up from the bottom makes it flat with the surface. That should be a lip. Let's zoom in here a little bit. There we go. Okay, got a lip there on the outside. Good. And then if we want to get fancy, I mean, we don't want to cut ourselves on the corners here, right? So we can click on that edge and put a little, let's see, where's the, somewhere in here, there's going to be, we've got a chamfered edge, rounded edge. So that'll round off that edge. Oops, click OK. So we'll round off this edge here, just highlight the edge, and it really helps having a larger screen. Normally I'm running at 1920 by 1080. And, okay, so zooming in, you can see what we've got here. Nice rounded corners. You can do that all the way around on the other edges, just to make things nice and neat. And that's it. We now have a lid, we have a box designed. We take the box, the body, file, export, and let's go up one. Nope, didn't want to do that. Oh well. We're just overwrite. Yeah, well, this is a copy. Everything's here is a copy. Okay. Anyway, I just want to know what I exported so I can. That's with the tabs. Okay, good. That's fine. So that's an STL file. That's the CAD drawing as a 3D model is now in a form that we exported, and we import it into a program called Cura. Open this up, and it was this one here. Okay, there's our box. And what you can do with when you this is basically laying out how you're going to have it actually printed. It defaults to XY face, sitting flat down, which is why the XY plane was so important. You can flip it if you want. You can, if you want to print it at some angle, you can move it around. But at this point, just the default's good. Hit the slice button, and it goes through, and it comes up with a file called G-code, which is the machine language for the printer. You put that on an SD card, stick it in the printer, and off you go. Starts printing. And usually slicing takes less time, but this laptop is not. Still faster than printing. And it's faster than walking the aisles of Home Depot. Right? Also the time it takes with getting the drills and the safety glasses and everything else. Now it says 6 hours and 57 minutes. I don't believe that's going to be how long it takes to print, but maybe. It take a while. Anyway, that's kind of the demo. Okay? So if you want to build a box, so there's a box, and it's got air holes on one side. I got a little fan grill on the top. I got things on the side here. I've got stuff inside, little mounting holes. Box. Took me, morning to design this thing. Took me all day to print it, but there it is. It's the exact proper size for what I needed. Questions? Who's going to keep grazing the aisles of Home Depot?
I'm going to come to your house.
So the thing you got to do is go to the ham swap, buy some tickets, and win the 3D printer from the ham swap. Question?
What OS do you have in your laptop?
This is OpenSUSE 15 something. I think it's Tumbleweed actually. The laptop is I think something's clogging the fan, so it's overheating and it's throttling itself down. Sorry? Other questions? Gary?
Yeah. Say I don't happen to win the 3D printer at the weekend. How much does it cost to get a decent 3D printer that would be usable for projects like this?
The one I've got is, yeah, the question for a usable, what's the cost to get a decent 3D printer? The one that we're offering at the ham swap is not a bad example. It's an Indra 3, Indra 3 V2, I think. I hope it's version 2. It's 300 and something, a couple $100. Not bad at all. And a spool of filament cost you $20. My first spool lasted me about a year and a half, and then it got waterlogged. My mistake. So I bought another one, $20. It lasted it was forever.
I can save that much on gas in a year going to Home Depot.
You can easily save that much on save that much on gas and your time at Home Depot, and yeah.
Really cool.
And you can the things are really cool. And they all and you can get different colors. Everything I'm doing is white right now because that's the filament I've got. But yeah, they come in different colors. You can get different materials. You can 3D print in wood. It's plastic with wood filler in it, is what it is. Carbon fiber, even, I think they've got something like that. They got some pretty exotic ones. So yeah. There's also, Brian, who did the box that you had for your, that scanner thing? Was like multicolored? Was really cool plastic. Anyway, there's, yeah, great fibers out there, filaments out there. Good question. Other questions? Thank you.